Alrighty, this is the Astro log, Stardate June 30th, 2022. In this edition, well, right now I'm just doing a little quick prep. I'm uploading some footage. Oh, did it finish? Oh, I think it finished. Okay, good. So, I can show that in a moment. But, basically, I was doing some preparation for tonight's astrophotography session, assuming the skies remain clear. And it occurred to me that I'm not currently streaming yet. Let's make sure I'm streaming before I do anything. Yeah, I'm streaming. YouTube says I'm streaming. I believe I'm streaming. I don't know if I'm using the correct stream. Can I resume the same stream? And excuse the aluminum foil on my right. Alright. I just stopped and started the stream. So we'll give it a good 10-second count. Or 5, 4, 3, 2, 1. And I am only... Oh, it's a private stream. Alright. We have now made this into a public stream. Is YouTube going to acknowledge that? No, I have to stop and start again. Okay, there we go. We are on, and we have action in 5, 4, 3, 2, 1. I know you're supposed to do it backwards. Just go 5, 4, 3. There's like a cool way to do it. I'm not gonna do it. But anyway, 5, 0, 1. Okay, so action. We are on. I'm going to edit any of the beginning portion of this video, which does not need to remain. So yeah, this is the Astro log, Stardate June 30th, 2022. You know, we got clear skies tonight, so I had the hope that I could do some preparation work on my telescope. So to that end, I wanted to set some limits on the equatorial mount, and I'll explain on what that means. Basically, well, I should explain what that means right now. So let's see, file number 451. I want to find a video file that will illustrate this quite conveniently. Alrighty. I got multiple videos here. I'm gonna mute the audio. Okay. Good, I think we found a video here. Okay, that's one. Okay, good. Almost got it. What I'm trying to do is find a video which illustrates what I want to point out in the most clear manner possible. And so far, all 3 videos which I've opened are just like kind of vague about this. So, okay, this is good. Okay, this is kind of good. A little not good. Okay, one more video. There we go. Okay, this should be the correct video. Okay, so that's my astrophotography rig. Now, what I wanted to do was set some limits, and I'll show you what the software interface looks like in a moment. But essentially, you start off in the parked position, which is like pointing at Polaris, the North Star, which I probably shouldn't do that with my hands. And what you do is you point it both east and west in order to hit the limit. So I just pointed it west. So you literally take the remote control or the software and you tell it slew west. So I brought it almost all the way west. But what I did was I stopped rotating it right around 90 degrees or whatever this is. And then so far we've been rotating the telescope on the declination. I'm sorry. So far, we've been rotating the telescope on the right ascension axis. So if this is my telescope mount, it's designed in such a way that I'm pointing at a star and it rotates as the Earth rotates, or at the count of the Earth's rotation. Then declination is when you rotate the telescope at the end of the arm, but the right ascension will always move the same way. No matter which way I rotate my declination, the right ascension will always move like this, because that angle, that 40-degree angle that the mount is actually set to, you see this little black object in the middle, that is actually my polar alignment camera. That camera is aiming at a 40-degree angle because I'm at a 40-degree latitude. And so in order for that camera to point at the celestial North Pole, which is where Polaris is, you know, basically in that general vicinity, I have to point that camera at Polaris and that general area by adjusting the mount. And once I've done fine adjustments both left and right and up and down, we have polar alignment. And so with polar alignment, you can rotate it along this side, like in the video here, and that is literally, no matter where the top half is pointing, this rotation will always counter the rotation of the Earth. So as the stars are moving through the sky because the Earth is rotating, this motion will keep them centered. And hey, what's up? What's up, Doc? What's up, Brandon Looney Tunes Fan 2000? Shout out to Brandon Looney Tunes Fan 2000. Check out his YouTube channel. You can look it up by searching Brandon Looney Tunes Fan 2000. Also, interesting thing, I was watching, I think, Pacific 414. He has a gentleman who has a YouTube channel named Pacific 414. I noticed something interesting. When I'm watching a lot of people's YouTube channels, if I click on a name in the chat box, it just gives me two options, which is like block or report, which I don't want to do either. But if I click on a name in the chat box on Pacific 414 channel, it gives me like a third option. Now, this is my own channel, so the menu shows me more options. But on most channels, I can hit report or remove or something like that. But on Pacific 414 channel, I click on this button and it says like go to channel. And I'm like, I want that on my channel. I don't know if he did something special in his settings to get that, but every chat box, every chat room should let you do that, because it makes sense. Like, somebody's watched my video, they look at the chat room, they see Brandon Looney Tunes Fan 2000, and they can click on his name and go to his channel. I think that's how it should work. So I don't know, I just thought that was worth noting, and I'm glad that he left a chat comment, because I wasn't really sure if I had this set up correctly. Alright, so getting back on topic. So we get to the end of the motion, or I set my end, and then what I do is I move the declination, which I'm not doing here. This video does not show anything important. There we go. In this video, you can see the declination is already rotated in a weird position, actually. And what I'm trying to find is a specific example, which unfortunately looks like I don't have that specific example right here. Basically, okay, there we go. So imagine the back of the telescope where that camera is going, but on the opposite side, which I know, mad annoying, you gotta flip it in your head. And at the end of the night, as the sun is, you know, setting, or as, I'm sorry, not even as the sun is setting, but as, let's say I go to bed, I'm following a target that's at the top. Like this. As the night goes on, it's going to continue going west. But at some point in the evening, it's going to get to the end of the horizon, and there's going to be no point in tracking a target that is underground, because, you know, once it goes below the horizon, you can't see it no matter what. The ground is blocking it. So that issue is, guess, how can I illustrate this? I didn't want to illustrate this. I want to show it in the video. That's the whole point of doing a video, is to show how this works. So, okay, so right now we're like at the horizon, but there's another form of rotation. So the scope is pointing like this. but we can also rotate the declination so it's pointing straight up. Now, the back of the telescope, if I was pointing this scope straight up, the back of the telescope would actually bump into the tripod, which, you know, is like a tripod. Boom, boom, boom. And so, when I go to bed, I either have to turn off the thing, but I don't want to turn it off. I want to go to bed and let it keep running. Problem is, if I let it keep running, like even in this position, imagine if this kept going west. Eventually, this stuff would bump into this stuff, and the motors would just keep trying to go. Luckily, it doesn't burn out the motor yet, but there's a way to deal with this. What we do is we set limits, and so in this video, I'm going left and right, back and forth, trying to probe the limits. This is it. Okay, this is as good as we're gonna get. So, in this portion right here, you can see the back of the telescope where the camera equipment is mounted will eventually bump into the tripod if it keeps moving west. So what we do is we go into the software and we set a limit. And this video was taken on my camera phone. This video was taken using an application called X Recorder, which is really just a screen recorder. And so let me just make sure I got the right video. Okay, good. So this is the software. These are just some of the numbers, and this is a altitude azimuth grid of the sky. Basically, it's like an imaginary dome over my head, so that I can judge what's going to be directly overhead at any given time. And I basically press some buttons, and you can see the little target HUD, which represents the scope moving down, 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 because I'm trying to pick a low target. Now, what you're not seeing in this video is the important part. So the important part is the limits. So hopefully this video will show us. Okay, in this video, I'm just complaining, going blah, 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 blah. Here we are, this little circle here, which I recorded using a screen recorder on my laptop, but my laptop is downstairs and I don't feel like getting it. So this circle represents the rotation. So when I was showing the thing going left to right, that's what this is. So what we want to do at the very least is maybe set a limit where this little yellow line is. But realistically, you could move it a bit lower. But it's not so much that it's going to bump into anything when it's going like this. It's when the declination goes like this, and then it keeps moving. Something's going to bump into something. So, and there we go. When you apply limits, and I go to bed, it'll keep moving. But by setting limits instead, or by applying limits, as I said a second ago, it will stop it from moving when it reaches a certain point in its range of travel, like that little triangular thing represents. Now, one of the issues I ran into is the wires. When I was trying to move it to the far left and the far right, back and forth, the wires were hanging from the telescope. So, you know, I guess imagine this is like the tripod and the thing is going at various points. A wire that is supposed to be like dangling would go and wrap itself around the telescope. And then the telescope would go to move somewhere else and it would go and it wouldn't be able to move any further. And so that's what I'm kind of illustrating in this clip. I'm kind of just jerking the wires around saying this is pissing me off. And so in this video clip, you can also see like a wire got wrapped around. In fact, this wire actually got wrapped around the freaking thing. So what was happening was I was moving the scope and it wouldn't move anymore in a given direction. It stopped moving. So I have to tell the software to move this thing, blah, blah, blah. And now it's unsnagging it. Absolutely frustrating. Now, this normally doesn't happen to me because I've already, you know, routed my wires, tied them up where it was appropriate to Velcro or tape them down, and then I was good to go. But because I had to set some limits, because I haven't set the limits since the last time I took my scope apart, I had to do the limits again. I now am moving this thing to the extreme front, extreme back, extreme west, extreme east, north, south. And apparently going through these contortions makes it more likely that this bullshit happens. Now, I could have prevented it by keeping a very close eye on the telescope. So instead of sitting in the kitchen, I could get off my ass and stand in front of it with the remote in my hand. If that is what I should have done. Instead, I tried to do it from inside, then it got snagged. But I said, you know what? Ballpark estimate. I can still set a limit based on a ballpark estimate. But kept snagging anyway because, you know, one wire already got detached and it stretched another cable and it moved some stuff over, so yeah. And the problem is the motor thinks it's still moving, or the telescope mount, all it knows is that the motor is moving. The software knows that the motor is moving west or east. But the cable is preventing it from moving, so there's actually like a clutch that will allow it to slide, even though it's been tightened up nice and tight. If the cable is strong enough, the clutch will slip. And so when it's supposed to be moving, the motor will get stuck, but the mount will keep moving. So it's like a little weird, hard to describe, but you get slippage. And when you park it back into the home position, when you put it into position 0, it is then... Man, I can't wait to take this down. I put this up because the sunlight is so bright. There we go. Alrighty. Much better. So yeah, the sunlight was so bright before. So anyway, yeah, so I don't know, it took me what, how many minutes to say all of that? 18 minutes to save that. So I'm just gonna say from the top right now. This is the Astro log, June 30th, 2022. And earlier today, I was using the EQ mod or EQ ASCOM software to assist in setting limits. And so in this picture here, you see like a little circle down here. That circle represents the position of the right ascension. So when the mount moves left and right, or east and west, and I'll show an example of that in a moment. So let's see if we can actually get close. So at this point, I think I was trying to go to the far horizon. Well, that's interesting. And it was no bueno. Yeah, I took a great video on my laptop. I think I'm just gonna have to upload the video from my laptop. I don't want to dig up my laptop, but I mean, it's not I gotta dig it up, I just don't want to get it. Okay, perfect. This circle represents the position of the right ascension, and you can see up here, that's the telescope mount. It's basically flat with the horizon. Now, if you give me a moment, I will retrieve a video which further demonstrates. Okay, so that's flat with the horizon too. And problem I was having is these wires, like this wire here, wrapped around the edge of my filter wheel, and it would stop it from moving. Sometimes I would move it west, go to the software, set a limit, and then when I told the telescope to park to the, original position, that is when it would give me a hard time. The purpose of setting limits is so that I can go to bed, and normally what happens is as the night goes on, this goes from east to west. Just like that. And if I go to bed, this will keep moving until something bumps into the tripod. And if it's pointing at this angle, it'll take longer for that to happen. But if the bottom here is, pointing straight down and the top is pointing straight up, when it gets past a certain time of the night, even if my target doesn't go below the horizon, at some point this will bump into the tripod. The filter wheel, the stuff on the back of the scope will bump into the tripod and keep moving. And then I have to loosen up the clutch, reset the position to 0 when I park it, and I have to basically redo the alignment routine. Now, redoing the alignment isn't super difficult, but it's just the fact that it was already set up. It was already aligned. It was good to go. Like, I turn it on, I point at a star, I'm good to go. But because I have to redo the alignment, now I have to wait for the sun to go down so that I can see some stars. Redo the alignment. I do have a workaround. There's a couple of different ways to go about alignment. So normally you start by doing polar alignment, and that's why there's a little camera up here. This little camera is actually there to assist in polar alignment. And if I didn't have that little camera there, there's actually a cap, a little cover that I put in its place, and the mount itself actually has a built-in there we go. A built-in, what do you call it? The mount itself has a built-in polar scope, they call it. It's like a little tiny telescope whose sole job is to, allow you to look through and see a little circle and line it up with Polaris. So, let's make believe this is my backyard. This is the northern sky. Now, you could put a, imaginary dome over your head. This is the altitude azimuth grid, and it's basically an imaginary dome. No matter where you stand on the earth, you can, use a dome that is relevant to your position. But a more accurate way and, global way is to use the equatorial grid, which, as you can see, I still have a dome over my head, but we have this circle in the northern sky. And what we're going to do is we're going to turn off the azimuth grid, and you'll notice that unlike the dome, which has straight lines that run parallel to the ground, you have this circle here. And when I'm looking at the northern sky, it looks like a tight circle. But as you move away from the celestial northern pole, you get these arches. And the reason for that is because technically, this point here is directly the opposite of the celestial North Pole. So the celestial North Pole is like where Polaris is, the North Star. But if I was in Australia or the Southern Hemisphere, I would have to use constellations like this Octanus one or this Oct one. Some of these constellations here, where's the Hydra or some shit. Well, basically, if you live in the Southern Hemisphere, you don't have a South Star, you don't have Polaris or the North Star, so you have to pick a couple of, known constellations and follow their circular journey around the sky. And this alone disproves the flat Earth. And anybody who argues with you to the death about this, really just didn't look into it at all. Or they don't want to know any better, and they're just as guilty as the people they accuse of being indoctrinated for not understanding why the earth is round, Because look, there's people, they will argue to the death that the earth is round, but they don't actually know how to explain it or back up their knowledge. And I'm not saying you have to, but if you're going to argue the point, yeah, you probably should know how to back it up. So now, let's go back to the northern sky. I'm going to turn off the altitude azimuth grid. Whoops. So once again, imaginary dome. June booties. It says booty. Well, it doesn't say booty. But anyway, and we're going to turn on this one only. And so what I mean by polar alignment is I use a polar finder scope to look at Polaris, and on a polar finder scope it'll actually have a little dotted line circle that runs like along the path of Polaris. And if I fast forward a little bit, you can see Polaris is moving in a tight circle. It's pretty much like the arms on a 24-hour clock, which we usually have 12-hour arms, but it's the same exact thing as a 24-hour version of a 12-hour clock, which they have. They have 24-hour clocks that go from 0 to 24 or 0 to 23 and back to 0. So what you do is I point my telescope at a 40-degree angle. I point the center of the polar axis. That's what you're seeing here. This thing here, the middle here, is already angled at a 40-degree angle because my latitude in New York is a 40-degree latitude. And what I'm looking at in the center is technically the actual celestial North Pole. But when you look at it from far away, it basically looks like Polaris is in the center. It's technically not dead center, but it's close enough. That's why we call it the North Star. And if you can align that circle so that your polar finder looks like almost like a rifle scope, if this moves along the dotted lines in the circle, then you got polar alignment. However, you got to be patient, you got to get on your knees, and I don't want to get on my knees and look up the ass of the telescope to look through the polar finder scope. So instead I mount a USB camera to the scope, and that USB camera uses software that will allow me to accomplish this task. Is my audio too loud? Sound check. Testing 1, 2. Might have to adjust my audio. I'm not really sure. I see it jumping into the red zone. I might be talking a little bit too loud. I'm not really sure which, but I don't like it when I see the red LED blinking. Anyway, yeah, red LED blinking on my microphone. Sound check. Okay, I'll do that later. So yeah, polar alignment, and then with that being set up correctly, you can rotate this part between east and west. And you will be able to counter the rotation of the Earth. And secondly, the more important thing is that you have an object in the center of your view. Because you could technically, like let's say the moon was shaped like this. You could use a non-equatorial mount to track the moon as it's going through the sky. But see how like as this can is rising and setting, it moves in an arc? The top of the can, it doesn't move like this. It moves like this. So if I have a telescope tracking the target, if I have it mounted like this, I can still go, but the problem is that when the telescope does this, instead of doing this, the object will actually rotate in the viewfinder. So essentially, I'll be following the target left to right, and it'll stay in the center of my frame, but it'll essentially do this. So this funny design of the equatorial mount, or what we call a German equatorial telescope mount, is to prevent what we call field rotation. Another example is you can look up videos where people will be arguing that there's a big conspiracy, that the government is lying because when you look at the moon or the sun or something like that, the moon and sun are upside down depending on what time of the night you look at them. And if you're not using an equatorial mount like this one here, yes, the sun, the moon, objects you're looking at, Jupiter, they will rotate in, like even if they're staying in the center, they will rotate. The design of this mount will prevent that. Oh yeah, and by the way, this is the polar finder scope. So once again, you basically make Polaris follow the rotation of this ring. Sort of. There's actually a ring in the viewfinder itself. And I basically replaced the full polar finder scope with a camera because I'd rather look at my laptop screen, or I can remote into my laptop and look at my phone screen and perform polar alignment with great ease. And it takes out a lot of the guesswork because the computer tells you if you're aligned correctly or not. It tells you, okay, adjust it to the left, adjust it to the right, go 3 degrees left, half a degree right, and then when you're done, you lock it in, and you could run the camera for like a minute or 2 or longer to verify that you actually are polar aligned. Once you're polar aligned, you got to do like 1 or 3 star alignment. You don't technically need to do 3 star, but what that is basically, it's telling the motors where you're positioned. So I'm in the position 0, but what you do is you tell the software, point at Vega or Altair, and then the telescope will point at Altair. Then, after pointing at Altair, it'll ask you, to refine the target, because technically the scope doesn't really know what Altair is. The star map will tell it where to point. Then once it points at Altair, if this is the center, maybe the star you're intending to point at is over here. So you then manually recenter it using the remote control. You put the star into the center. Then you tell the software, we are now locked on target. And then next time you point at the same target, it'll know where that target is because you told it. Not only that, by telling the telescope the correct position of one target, it'll know where all of the other targets are. Because of course it is well known that if this star is over here, this star and that star and that star are all over here. And so 1 star alignment is usually enough. I usually do 3 star alignment, but I'm lazy. So once I do that 3 star alignment, because I feel it's more accurate, but once I do that, I don't want to do it again. So when the motors get stuck, when the telescope bumps into itself and the motor keeps moving and the clutch is slipping, what I do is I like to how do I phrase it? Just loosen up the clutch manually. So I'll tell it point at a star. It'll be slightly off target because I screwed up while doing, because a cable was snagged on it earlier in the day. Remember, the thing was moving and a wire wrapped around something and it couldn't move it anymore. So the scope thought, the mount thought it was moving west when it was actually stuck. So what I do is I tell it to point at an object, then I loosen up the clutch, just like loosening a tripod up, and I manually aim it by hand. And I look at the, screen. I'll put my screen on the bottom of my tripod like this, and while I'm manually moving it, I'll try to center it on my screen. Then once it's centered on my screen, I'll lock it down, maybe nudge it a little bit, and then I can pretty much park the telescope, test it out, make sure it finds the target automatically, and once I do that, I'm good to go. And I could proceed with my astrophotography. Where was I? So, because I was redoing the alignment today and multiple times wires got snagged, like these wires wrapped around things because I was trying to set the limits, I lost my alignment. So I gotta redo the star alignment. I don't have to do polar alignment. I have to do star alignment. And basically I want to make it so that this part cannot bump into the bottom here. And so that when I take pictures of objects tonight, maybe I do like 5-minute pictures of, 5-minute time exposures of a nebula. I can then go to bed, let it automatically take pictures, and when I wake up, whether I wake up at 8 a.m. or 12 p.m., I don't have to worry about this stuff bumping into the side. It'll either do a meridian flip or the software will stop. It'll say, oh, horizon limit, can't go any further. And that's good. What we don't want it to do is to try tracking targets past the horizon, because 1, it's pointless, and 2, that increases the risk that something is going to bump into the tripod. So that's basically the end of this astrophotography log, until later on when I either do a live stream or a log for today, because technically this is daytime. I guess the next log would be for tomorrow's date or nighttime. But what we have in the pipeline is I still got to make a video on how to set up the virtual machine, which allows you to transfer Nintendo 64 memory cards to a PC. Secondly, I keep putting this off, but I want to test out my PS4 controller in modern games, and maybe I'll stream that too, but that's not really a streaming subject, just something I want to do. Still got the N64 with the HDMI working, so I'm glad that's been working, because originally I was getting a lot of problems with that, and I solved it. I emailed all of the tech support people, told them, hey, thanks for your help. Luckily, I solved it by cleaning it. Well, long story behind that, but you know, but I've been using my little flash cartridge here, pretty cool. I still have a stack of Nintendo 64 games, but you know, I mean, I'm not gonna pay $100 for a Yoshi story. Well, what else do we have in the pipeline? I gotta repaint my Orville. Like, I crushed it like a week ago. A family member put a toolbox on top of my Orville, and it damaged the quantum struts. Like, cracked it off, clear off, cracked right off. So I put glue on it, and I redid the putty, and that's what you're looking at. This white stuff here is the putty, the modeling putty. So now I just have to brush it. I might use a darker shade. I think I'm going to stick with the Season 1 color scheme, and then next time I 3D print one of these, maybe I'll investigate editing this 3D model, or investigate creating a stencil, so that I can, you know, more accurately represent the color scheme of the Orville as we see it now, because the exterior model has been updated for the Orville, so we should accurately reflect it. And what else? Gundam Crossfire, got a couple of Gundam Crossfire streams. Gundam Crossfire for PlayStation 3. Next time I stream it or talk about it, I'll talk about the positive and negative aspects of the game. And finally, streaming for my bicycle. So this is my DJI action camera, and this camera is wonderful because it's very stable. It's got a gimbal that will lock the target. So basically, like, when it's on, I can make it so that the gimbal stays still, and when I rotate the camera like this, or when I move the camera, it stays. Like, literally, you'll do this, and the top half of the camera will remain stationary while you move it around, which is really cool. Right now, I'm transferring data off of the camera while I get ready to go out. If I go out for a little bike ride, even though it's sundown already, I want to ride my bike. But the data transfer on SD cards is really slow. I mean, look at that, that's brutal. 29 megabytes a second. It'll take a freaking half hour. What a bummer. But what we wanted to do was, I bought a wireless module for this camera, which, even if I don't use it for, you know, bike streaming, it's still useful because it doubles as a stand. I could literally stand the camera up on it, power it externally, and use this in my backyard when I'm doing astrophotography, which I might do tonight. So this will come in handy. But I had a couple of problems. So when I use Streamlabs from my phone, I can't use my whatchamacallit, Bluetooth headphones. So I have another phone I use for streaming, and that works. But instead of taking the SIM card out of this phone and jockeying it back and forth, I simply connect one phone to the other phone using Wi-Fi, which is all fine and dandy until you realize that you want to use a Wi-Fi module to link the camera to the phone. So I'm gonna work something out, and I'll either have to sit down messing with it, or I might just go and do it in situ. So right now what I'm gonna do is I'm gonna go get my wireless Bluetooth headphones. I'm gonna connect them to this phone, and I'm gonna test it out with OBS to see if the audio comes from the Bluetooth headphones into OBS. If it does, then I'm gonna go and stream with just this phone. If the problem that I was having continues to happen, then I will either have to jockey the SIM card out of this phone into my other phone, or make compromises. But my goal is to have the ability to do the following. I want to have a phone attached to the handlebars of my bicycle. I want that phone to be connected to a camera that is facing the front of my bicycle. So far you got phone and camera facing forward. From there, the video from that camera is going to be sent to my phone either via USB cable or Wi-Fi. And then my phone has a camera facing me. So what I want to be able to do is show people what's in front of my bike while I'm riding my bike, live streaming it, while I talk to people using my selfie camera. And I want people to hear me through my Bluetooth headphones, because the microphone down here isn't designed to work when it's on the handlebars of a bicycle. You know, you're gonna have wind blowing on it and making all kinds of background noise, plus the cars and vehicles around you. But my Bluetooth headphones are specifically designed to filter out ambient background noise. So the only problem was I couldn't connect them to Streamlabs for Android on this phone, but I was able to use the Bluetooth headphones along with Streamlabs for Android on my other phone. And so we're going to try that out right now. But with that, I thank you for watching. Maybe I'll stream later on and end transmission.